patient is taking 2 500 mg sodium bicarbonate capsules 3 times a day. How many grams of sodium is he taking daily to 2 decimal places? And for this, we're given the formula for sodium bicarbonate, which is NaHCO3. We're given the atomic mass of sodium, which is 23, and the molecular weight of sodium bicarbonate, which is 84. So first of all, we work out how much sodium bicarbonate he's taking a day. So he's having 2 500 mg capsules 3 times a day. So 2 times 500 times 3 means that he's taking 3,000 milligrams of sodium bicarbonate a day. Now, it's important to remember at this point that molecular weight is expressed in grams, not milligrams. So at this point, I would convert that to grams. So 3,000 milligrams is the same as 3 grams. Now we need to calculate the number of moles of sodium bicarbonate in 3 grams. And the equation for this is that moles equals the weight divided by the molecular weight. So in this case, it's the 3 grams divided by the molecular weight we're given. That's 84 for sodium bicarbonate. So 3 divided by 84 equals 0.03571 moles. And that's moles of sodium bicarbonate. It's not the moles of sodium at this point, it's the moles of the sodium bicarbonate. I'd also like to point out at this stage that we must remember that figures should only be rounded up or down at the end of the calculation, so at the point of the final answer, not in the middle, because that can lead to errors in your final answer. So we'll leave that at 0.03571 at this stage. So we're actually being asked to calculate the weight of the sodium, and we now know that we have 0.03571 moles of sodium bicarbonate. So the equation to calculate the weight of sodium is that weight is equal to the number of moles times by the relative atomic mass. So we've just calculated the number of moles, so that's 0.03571, and we've been given the relative atomic mass, which is 23. So this equals 0.82133 grams. Now this is our final answer, so the question is asking us to round it to 2 decimal places, so we can do so at this point. So to 2 decimal places, this equals 0.82 grams. You could remember to apply a reality check at this point. So 0.82 grams seems a reasonable consumption of sodium. However, if you'd forgotten to convert to grams and you got an answer therefore of 821 grams, then hopefully a reality check would tell you that this couldn't possibly be correct. A person cannot be taking nearly 1 kilogram of sodium a day and surviving. Okay, so that's the first method. So we'll now apply the second method, which is to use proportional sets, if that's your thing. So let's just get rid of these scribbles. Right, so using proportional sets, we first of all draw the table. And in this table, we have sodium bicarbonate, and we have sodium. We have the molecular weight, so the RMM or the RAM, and we have the weight in grams. So what we know is the relative molecular mass of the sodium bicarbonate and the relative atomic mass of the sodium. And we know that the patient, you'd still need to work out that the patient's taking 3 grams a day. So you still need to perform that part of the equation. So 2 by 500 times 3 equals 3,000 milligrams, and convert to grams is 3 grams. So our unknown we will call y. So 3 over 84 would be equal to y over 23. So y is equal to 23 times 3 divided by 84 equals 69 divided by 84, which rounded down to 2 decimal places again equals 0.82 grams. So that's the second method, using proportional sets, if that's your preferred method.